This session is our number properties test revision or practice test for Year 7 2025. So first question says, who am I? And we've got three different points with information. So always read through these carefully and do it step by step. So I am a multiple of 7. So straight away, we can think of multiples of 7, like 7, 14, and 21 and so on. But it says I'm in between 50 and 100. So what you could do, you can start from 7 and do a snail trail, a list of multiples of 7 all the way to 100. Or I'm going to start from 56 because I know 7 times 7 is 49. So 56 is in between 50 and 100. And I'll keep going. So keep adding 7. So 77. I know 7 times 12 is 84. And then I'll keep adding 7. So 84 plus 7 is 91. 91 plus 7 is 98. And I'll stop there because then I'll pass 100. So all these numbers are in between 50 and 100. And the last point says I am odd. So odd numbers end in 1, 3, 5, 7, or 9. So odd numbers must end in one of those digits. So I can see 63 ends in 3, 77 ends in 7, and 91 ends in 1. So they are my three possibilities. And it did say 3 options there. So we've got 63, 77, and 91 as our 3 options. With the next one, so same sort of process. It says I am a multiple of 3. So I think of 3, 6, 9, 12, straight away. I am between 1 and 10. So that's not a huge range. So I can just write them out now. So I've got 3, 6, 9. They are the 3 numbers in between 1 and 10 that are multiples of 3. And I am even. And we know even numbers are the opposite of odd numbers. So they have to end in 0, 2, 4, 6, or 8. And that's the only option is 6. So the number is 6. Now, number 2, which of these numbers are factor pairs of 26? So remember, factor pairs means we multiply 2 numbers to get, in this case, 26. So I know 1 times 25 is not 26. So 1 times 25 won't work. 1 times 26 will give me 26. Oop, just here, 1 times 26. So yep, that's a factor pair because that equals 26. 2 times 24 is 48. That won't work. 2 times 13, if you try 2 times 13, it actually gives us 36. So that's a factor pair. And 4 times 7 won't work because that's 28. So you had those 2. Number 2, which of these numbers are factor pairs of 32? So once again, if I go 1 times 31, it's not 32. 2 times 16, I know 16 plus 16 is 32, so that will work. 3 times 12 is 36, that won't work. 5 times 7 is 35, won't work. I know 4 times 8 is 32, so that's a factor pair of 32. So there are our 2 options there. With number 3, so we're going to fill in the following table. So first one asks us, is it a multiple of 3? And they've got the first one done. 15, yes, is a multiple of 3. I'll focus on just multiples of 3 first. Is 13 a multiple of 3? If it helps, you can do a snail trail for 3. So like 3, 6, 9, 12, 3, 6, sorry, it's supposed to be 9, 12, 15, 18, 21, 24, I'll do one more, 27. So if it helps having a visual, just quickly do a snail trail. Now, is 13 a multiple of 3? No, it's not in the 3 timetables. So we'll just write no. Whoops. Is 6 there? Yes, there's 6. Because I know 3 times 2 is 6, so that works. 10? No, 10's not a multiple. There's no 10 there, so no. Is 4 a multiple of 3? No. So right, no. Is 21 a multiple of 3? Yes, there it is. I know 7 times 3 is 21. So yes, it is. And 12, 12 is a multiple of 3. So I'll write yes, because I know 3 times 4 is 12. So that works. All right, and this time it's asked us a factor of 36. Okay, so can these numbers, can they be divided into 36 evenly? So I know I can't go 36 divided by 13. That won't work, so no. With 6, I know 36 divided by 6 is 6, or 6 times 6 is 36. So yes, that works. 36 divided by 10 won't work. It doesn't end in 0, so I know it won't work. Now, what's half of 36? Half of 36 would be 18. So that means 21 has already passed the halfway mark. So it cannot work. 21 plus 21 is 42. So no, that won't work. And I skipped 4, sorry. 36 divided by 4 works because I know 4 times 9 is 36. So yes. And the last one, I know 12 times 3 is 36. So that works. Okay. So have your timetable chart handy as well because that'll help with this. Alrighty. Number 4, list all the factors of 60 in ascending order. So remember, when listing factors, the best way to do this so you don't miss out on a number or a factor is start with 1 and the number itself. All the factors are in between those two numbers. Okay. That's always our starting point. 60 is even. So I'm going to write 2 and half of 60 would be its partner. So 2 times 30 gives me 60. And if you do it this way, you won't miss out on a number. I'm going to try 3. I know 3 works because 3 times 20 is 60. So 20 is its partner. And we're narrowing down our range. Next one, I'll try 4. Now 4, I know works because I know 4 times 15. So 4 times 15 gives me 60. And you can always use an algorithm to help you double check. I'm going to try 5. Because it ends in 0, I know 5 will work. And I know 5 times 12 gives me 60. And I'm done. I can double check after 12 we've got 13. 13 won't work. 14 won't work. And now once I reach 15, we've checked all our numbers. So doing it that way ensures you won't miss out. All right, number 5, write the first 10 multiples of 25. So multiples are not factors. Multiples, we keep adding that same number. So if you start with 25, what's 25 plus 25? It's 50. 50 plus 25 is 75. Then we get to 100. And we're going to see the same numbers appearing. In the hundreds, we have now 100 and there's 25. There's 150, 175, 200. And I think we need one more. So 225, and let's just double check. We need 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9. One more, and we've got 10. Just write 10, and that's all you need to do. With number 6, state the highest common factor of 42 and 24. Now, you might be able to do this mentally. I think if I was to have a quick think about it, I think the highest common factor is 6. Because I know 6 times 4 is 24 and 6 times 7 is 42. And I can't think of another number that's greater than 6 that will work. But if you want to double check, you can write the factors of 42 and 24 and compare them. But I won't do that because we're running out of time. So the highest common factor you should have, how you've done it, you should have gone, however you did it, you should have gone 6. All right, number 7, state the LCM, so lowest common multiple of 6 and 15. Now, when doing this, sometimes people go, oh, if I just times these two numbers, 6 times 15 will give me 90. Yes, 90 is a common multiple of 6 and 15, but is it the lowest one? Is it the smallest one? So if you did that, always double check because for this one, it's actually not the lowest common multiple. 90 is not. Now, a way to do this, you can do a snail trail for 6 and a snail trail for 15 and compare. I might try another way. Because I know my 6 timetables, I'm going to do a snail trail of 15, my largest number. So I'm going to start with 15. Now, I can't go 15 divided by 6. That won't work. 15 is not in my 6 timetables. The next one would be 15 plus 15 is 30. Now, as soon as I see 30, I know 30 is in my 6 timetables. 6 times 5 is 30. So that means the LCM will have to be 30. So I thought I'll try a different way to save some time. But if you found it more handy to have the multiples of each number, then that's fine. All right, let's turn the page. Now on this page, we have circle the numbers that are prime numbers. Now, if you remember what prime numbers are, prime numbers only have two factors, 1 and itself, but two different factors. So 1 is not a prime number. 1 only has one factor, not 2. 2 is the only even prime number. So 2 is a prime number that's even, and it's the only one. That means every other prime number must be an odd number. 3 is a prime number because all I have is 3 times 1 is 3 and no other options. 16 is not a prime number because I can also go 4 times 4. 19 is a prime number. I have 1 times 19 and nothing else. 27 is not a prime number because I know 3 times 9 is also 27. 39 is not a prime number. It looks like 1, but 3 times 13 gives us 39. So be careful with that one. 49 is not a prime number. That's in our timetables. 7 sevens are 49. 50 is not a prime number. It's even. 71 is a prime number. It's not in our timetables. And if you just try and divide it by 3, try and divide it by maybe 6, they won't work. So 71 is a prime number. And over here, it says circle the numbers that are composite. So composite numbers are opposite to prime numbers, excluding the number 1. Number 1 is neither composite or prime. All right, so with composite numbers, we have the same numbers listed. So it's just the numbers we haven't circled yet. So 16 is composite. It's got more than two factors. 27 is a composite number. 39 is, 49 is, 50 and 100 is a composite number. So they're our composite numbers. Now with this one here, find the prime factors of the numbers. So these ones, because the branches are already done for us, we have to try and work out factor pairs that fit. Whenever you see a circle, a branch stops. So that means the circles are prime numbers. So with 80, I'm going to just try 2 first because 2 is a prime number. And then half of 80 is 40. And I can break down 40. So I now know half of 40 is 20. So I'm going to put 2 in the circle because it's a prime number. And 2 times 20 is 40. And then keep breaking it down. I'll halve it again. 2 times 10 is 20. And then I know 2 times 5 is 10. And it all matched up. Now check all your prime numbers. How many 2s do you see? 1, 2, 3, 4. So do it in ascending order. So 1, 2, 3, 4. And then 5 is last. And always do a check. If I go this way, 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. 40 times 2, I got my 80 that I started with. All right, with number 2, something times something to give me 50, a prime number in there. I think I might just do 2 times 25 because I know half of 50 is 25. And then I'm left with 5 times 5. So it was 2 times 5 times 5. And do you check to make sure it's right? Here, 88. When I think of my timetables, I know a prime number is 11. So 11 times 8 is 88. And then I can break down 8 further. I'll put 4 here and 2 there. 4 times 2 is 8. And 2 is a prime number. And I'm left with 2 times 2 to give me 4. So my prime numbers, I have 2, 2, 2, and 11. So let's put them down here. 2 times 2 times 2 times 11. And we are done. All right. Express the number 90 in prime factor form. And you can use a factor tree to find the prime factors. All right. So when you see prime factor form, it means something like this. You have prime numbers that are being multiplied to give a composite number. Okay. And the best way to get all the prime numbers is, let's use a factor tree. So we can start with 90 and get our branches ready. Now you can use any factor pair. You can have 45 times 2. You can have 9 times 10. It doesn't matter as long as you break down the numbers correctly. All right, so I'm going to just stick with 9 times 10 because that's in my timetables. 9, I can break down further. 10, I can break down further. I know 3 times 3 is 9. And with 10, I know 2 times 5 is 10. Now, these are all prime numbers, so I can circle them to show, they're prime numbers. And now make sure we express it. So that means write an expression. So I'm going to start with 2 first because 2 is my smallest number. Then times 3, and times 5. So write all the prime numbers you see and just times them. And then because we've got 2 3s here, we can simplify that. I can write this 2 times 3, but squared to the power of 2, and then times 5. So try and go that next step as well. All right, list the first 10 perfect squares or square numbers. So if you remember, perfect squares are numbers that can actually make squares. So if I go 1 times 1 to get 1, 1 is a perfect square. If I go 2 times 2 to get 4, 4 is a perfect square. 3 times 3 to get 9, 9 is a perfect square. And you keep going. 4 times 4 is 16. And we keep going until we have the first 10. So you should go all the way to, the last one would be 10 times 10, which is 100. And stop there. And you can do the rest yourself. All right, find the lowest common multiple of 9, 3, and 5. Once again, you can try and do this mentally. I think it's going to be 45, but just say you couldn't, it was a bit tricky. You can do a snail trail for each one, but to save time, get your largest number and let's do a snail trail for 9 and work from there. So I'm going to write 9, and then 9 plus 9 is 18. 18 plus 9, it's 27. So this is my 9 timetables. 36, 45. Now I'm going to stop at 45 because I've got a 5 here. And I know multiples of 5 must end in 0 or 5. So my first one here has a 5 at the end. So far that's the only one that can work for all of them because I've got a 5 there. So it works for 5. It works for 9 because I'm doing my 9 multiples of 9. Would it work for 3? Now, 45 is not in my 3 timetables because we stop at 36. If I just do a quick algorithm, I'll have 45 in there and 3 out there. So I'm saying 45 divided by 3. 3 into 4 goes once, remainder 1. And 3 into 15 goes 5 times. So it does work. So the LCM, the lowest common multiple, was 45. And once again, if you wanted to do a snail trail for each one, if you found that approach better, then that's fine.